I received a comment that I should do a first look video, and I said, what is a first look video? And I checked it on Google, and it's something like unpacking something in front of a camera. So let's do this. If you're interested, let's have a first look video with me together, and be prepared. It will be horror, it will be a catastrophe. So what I want to show you today, Hugging Face, we go to documentation, and there's a course. And I like HuggingFace. I use them a lot. I think a lot of the models they host are great. So if you do not know HuggingFace, go and explore. And yesterday I found something here, the dataset library I want to show you. Introduction, let's go in the dataset library. Hey, come on, here we go. Introduction. And as you can see here, they give you a very nice introduction. Sign up. Okay, what's dataset isn't on the hub. They have a hub, yes. They have short videos. This is nice. CSV, TSV file, text file, JSON and lines file, pickles. Yes, I love pickles. Loading a dataset, wget, yes. gzip command, we do a lot. gzip command here, yes. Dataset, you can upload, download datasets. Okay, loading a remote dataset. Load dataset, okay. Time to slice and dice, this is nice. What is this about? Yes, okay, but let's go to what I'm interested in. Here you have the point, create your own dataset. And this is currently what I'm looking for, creating your own dataset. This is it. So let's say what HuggingFace has to tell us. And please, if you want, just go to this page, have a look together, and let's see what we can learn from HuggingFace about creating your own dataset for machine learning models. So sometimes the dataset that you need to build an NLP, let's make it a little bit bigger. Application doesn't exist, so you have to create it. Yes. Training a multi-label classifier. Yes. Semantic search engine. Exactly, this is what we are doing with our crossing code in emBERT, in SBERT, sentence transformer. So getting the data. So let's have a look how they structure this. Yes, a slow take. We are now, what are we doing here? I don't get it. HuggingFace dataset, so we are to, okay. To the GitHub issues tab. Okay, I see where there's the data source. So there are 331 open issue and 668 closed issues. Okay. Click on one of the issues you find contains a title. I see. So we have a title, a description, a set of labels that characterize the issue. Okay, this is the description. Okay, yes, I see. We have a title, the first red box, then we have a text field with a description where we have our content information in sentences or just in code. And then on the right side, we have some labels, project milestones. Okay, I see where we go. So to download all the repository's issues, we'll use a GitHub REST API to pull the endpoints. Okay. You have the request. Yeah, it's a nice library. Request, you get it. Okay, 200 means that the request was successful. Always nice to see. So this is now your JSON file you get back. Heaven's sake, is this one dataset? Body, GitHub, contribution, state, events, URL. Jesus. So, okay, we have a lot of information. What do we do with it? Great, a lot of information. I agree with this thing. Title, body, describe the issue. Click a few on the URLs in the JSON payload above to get a feel for what type of information is linked to. Your GitHub token, yes, if you operate on your GitHub. Let's create a function that can download all the issues from a GitHub repository. Okay, so we've defined a function. Define a function. Oh, this is all the function. Okay. This is our function. Define fetch issues. Number of issues. Batch, page. Where is the intelligence in this code? Where is my intelligence here? Query, okay. Issues, request, get. Here we download the information. If the length of the batch is, yeah, there's a rate limit, of course, yeah. You cannot download unlimited. I don't know what the exact limit is right now, but yeah. You have to be respectful because others want to work too on this platform. So you extend then your list, extend it with the batch data. You form a data frame from the records. Yes, okay. And then you have data frame to JSON. So download all the issues from the repo. Yes. Now we call fetch issues, download all the issues in batch to avoid exceeding GitHub's limit of the number of requests per hour. Okay, we respect them, cleaning up the data. Here we go. The first above snippet from GitHub's documentation tells us about the pull request column can be used to differentiate between issues and pull requests. Example, we'll shuffle, random, zip, okay. Print the all. Okay, you print something. Pull request, none, okay. Here we go, this is nice. Issue dataset map. Here we have a lambda function. My goodness. Isn't it not possible to have a, what's it called? List comprehension? Gee, Python was 10 years ago. Okay, so we go. Lambda is false if is, okay, simple. Augmenting the dataset. Yes, this is nice. As shown in the screenshot, the comments associated with an issue or pull request provide a rich sources information. Okay, so what we're interested in is more or less the comments. We want to extract the text, the semantic information, and building a search engine to answer user queries about the library. Okay. Okay. So this is what you see on a screen. If you go there, adding a data set, then you get some question and some answer and some blah, blah, blah. Okay. And GitHub REST API provides a comments endpoint that returns all the comments associated with an issue number. Okay. You download this. This is just blah. Yes. Okay. That the comment is stored in the body. Yes. Get comments. Good. This looks good. Dataset map. New comments. Okay. You just added. Uploading a dataset to the HuggingFace Hub. Okay. I don't think we are done with the dataset, but okay. Now that we have our augmented dataset, it is time to push it to the hub so we can share it with the community. Okay, so how does the dataset look like? Can you give us, please, a short example? I want to see what is the first 3 lines of our dataset, or the first 3 heads. What is the form? To JSON. Okay, so no idea what it is. They say now we have an augmented dataset. You push it to the hub, you publish it. You have a login, beautiful, yes. You have your login, yes. Import repository, yes, beautiful. Everything is there. Create a dataset card. The short information. If some other looks it up, that he gets a basic overview information on your specific dataset. You create the README file directly on the hub. Beautiful. So all the different information. And this was it. This is it. Create your own dataset. I mean, there was a lot about the REST API, which is great, but where's my dataset? What form does my dataset have? How can I use it? In a cross encoder for some semantic research? Okay, I see it here. Semantic search with face. Okay. So here we go. GG. Okay, let's do it one by one. In section 5, we created a dataset of GitHub issues and comments from the dataset repository. We will use this information to build a search engine. Okay, maybe we now see our dataset. Because this was just more or less a download with some cleaned data. The most pressing questions about the library. Yes, embeddings for semantic search. We know this because we are genius and we have read SBERT. Loading and preparing the dataset. Okay, from HuggingFace Hub, import Hub URL, yes, 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 store dataset, load the dataset, the JSON file, yes, split it, yes, into training dataset, yes. Filter, okay, you filter out, we see a lot of columns in our dataset, we don't need to build our search engine, yes, always. Also, they're still cleaning the data here. Okay. The most informative columns are title, body, and comments, while all their else provide us with a link to yes, yes, yes. So what we are focusing, title, of course, the body with all the information, and some comments. Good. So columns to keep. This looks like a data frame. Set symmetric difference, issues, remove columns, issue dataset, features, body, number of rows. To create our embeddings, we'll augment each comment with the issue's title and body. These often include useful information. The comments column is currently a list of comments for each issue. We need to explode it. Yeah, this is the typical Panda explode. We're familiar, we create single rows or single columns for a list or a list of list. In Pandas, we can do this with the data frame explode function. Hey, good old friend, here you see you again. And the data frame there to list, okay. So here we have a common example. The barcode located in, if that is not, yeah, okay, we have some sentences. If we explode our data frame, we get one row for each of these comments. So we go for one row for each of these comments. Great. Let's check if this is the case. What we do a data frame explode comments. So our column is now here the comments column. Ignore index is true, so we said that we start from 0 and we run up. And then we have, if this is now a list of all the different sentences in comment 0 cell, we have now here always the same, here the same, same. And here in the comments, we should now have our single sentences. So the first, the bug located in, the bug code located in, yes. And then we have hi in GNAG, and here we have the hi GNAG, yes. So we just exploded here a Panda data frame. So we get, let's say, single sentences, or single whatever you will call these elements. Well, because you have HTTPS elements in there, you have a lot of line breaks in there, you have some symbols that are Unicode, whatever. Great. We can now have rows have been replicated, column containing an individual comments. Yes. Now that we are finished with pandas, we can switch back to dataset by loading the dataset in memory. Okay, dataset from pandas, yes. And so we have title, comments, body, 2000. Okay. A few thousand comments to work with. Now that we have one comment per row, let's create a new comments length column that contains the number of words per comment. Okay, you do just a single split on a white space. You can use this new column to filter out short comments. Okay, so you want to get rid of the short little comments with 1 or 2 words. Comment length greater than 15. Yes, okay, so you do just still filtering the text. Okay, concatenate the text. You have text, example title, character return example, body, example comments. And we do a map on all this dataset. Beautiful. Creating text embeddings. Okay, we still have not seen our dataset. Why they do not show us the first lines of our dataset? I want to see the structure. What is string? What is the D type of all our... Okay, let's move on. Create text embeddings. We can obtain token embeddings by using the automodel class. Yes, of course. Yes, sentence transformers. Yay, hello, baby. Create embeddings. Yes. We use Jesus. A multi-question answer MPNet based version 1 from Microsoft. I do not like Microsoft, but okay. So you notice this is a standard sentence transformer. We have our model, we have our tokenizer, and we have from pre-trained sentence transformers. This is our sentence transformer. On a GPU, yeah, Torch device Coda, beautiful. Our GPU, we have the pooling layer. Embedding is clear. As always, I have 100 videos on this. Get embeddings, yes. Size definition, convert the first entry to a 768-dimensional vector. Yes, we know this. And we use a map function to apply our getEmbedding function to each row in our corpus. Okay, so we have the map function, no lambda. Embedding, CPU, NumPy, okay. NumPy arrays require the format when we try to index them. Okay. So here we go, the Facebook AI similarity search. Here we go. Facebook, another company I do not like so much, but okay. Now that I have a data set of embeddings, we can need some way to search over them. A special data structure in dataset called the Facebook AI Similarity Search Index. Basic idea behind it is to create a special data structure called an index that allows one to find which embeddings are similar. It just call the index. Yeah, but we can do better. I mean, hey, come on, with a sentence transformer, we can do better than just with an index function. But okay, yes, I hear. Yes, let's stay nice, simple, and clean. Can I load, get the embeddings? Yes, torch size, yes, embedding. Function returns a tuple of scores. You have a panda data frame from a dictionary. You have your scores. Now we can iterate over the first rows to see how well our query matched the available comments. G. Comment is this, and comment is this, and this. What? Comment. Okay, I do not get the structure of this comment. I mean, what's with all these special characters? I don't want to have this in my data set. Gee, then it's a lot of cleaning to be done before we can use this in any formal way. Check. What is the next one? Well, this was quite a tour through the dataset library. Okay, load datasets from anywhere. Yeah, we had HuggingFace Hub. This is beautiful. Wrangle your data using a mix of map and filter function. Yeah, you have the panda map and the panda filter. Quickly switch between data formats like pandas and NumPy. Okay, this is very advanced. Create your very own dataset. Embed your documents using a transformer model. Yes, of course, and the semantic engine. Okay. But it's a good use and take a deep dive into the task, the transformer models. Hey, in chapter 7, we go to the transformer models. Main NLP task. Yes, this is it. Token classification, fine-tuning a mask language model. Yes. Here is where the music is playing. Yes. Okay. This is just for the introduction. I mean, personal, I would say, this data frame, this data set here. Yes, okay. Create your own data set. I thought I would get a data set I can use right now, let's say for a cross-encoder semantic search, or I can use it for some zero-shot classification of my text, you know? But as you can see here, this data set is just more or less a dump from some internet data, but it's not at all prepared and structured in a way like SNLI or multi-NLI or all NLI, where you have your specific structure of sentence pairs, like, let's say, for example, for an SBERT application, that you can immediately use. What you have here on this data set, I mean, it's great. Yeah, you get the data, you download it, you have a lot of REST API operation, you have all the GitHub, you learn a little bit about GitHub. This is gorgeous. Cleaning up the data. There's a lot of cleaning up the data. Unfortunately, you never see the state of the data set when you enter the next step. And after this step, how does the data set visually improved? What changed? There's no before and after comparison, you know? I would maybe have like this one, so I will do in my next video. I write a memo to myself, do a before and after. Maybe there's some information here in this YouTube tutorials. I don't know, I haven't watched them yet. Now that you have your data set. So you see here already you have your data set. So you have augment the data set. So this is it, because here, if you go here on the right side, cleaning up the data, okay, whatever data set you have to have a special cleaning operation. Augmenting the data set. Okay, augment the data set. You can call it an augmentation. Yes, okay. I would still call cleaning, but okay, never mind. So we can push them to a hub. Okay, so this is a data set, a very general aggregation of data from the internet given a semantic topic here. Whatever it is, whatever you request, whatever you download. Okay, yeah, good. So creating your own data set in this particular course, I don't see how I could use it immediately for a semantic search query. That's a little bit more complicated. Or if you use a cross encoder, to use the benefit of a cross encoder, a bi-encoder like SBERT, to operate immediately on this data set. So we want to create, in the next video, I show you a very trivial example. I create maybe my own data set. I do a very fast demo code and show you what I mean if I create data sets and what I take care of and how I do it. But this is, of course, the next video will be a very personal video because there are 100 ways to do it. But I think it's great to have here a HuggingFace course, dataset library, create your own dataset. Download the data, clean it, structure it, augment it, upload it to the HuggingFace Hub, create the dataset card for the other people if they get a glance over, that they understand what kind of data it is. Okay, but we want to go in our next video a little bit more into detail and make it operational ready. I say thank you, and I'm personally now interested. The main LP task, what is it? What is it that they show you? Okay, token classification, GPT-2, question answering, okay. Oh, this was it. Translation, fine-tuning, yes. Yes, fine-tuning, mask, yes. Distilled BERT, hey, there's our distilled BERT model. Yes, hello, my little ones. How are you today? Yes, here we go. Automodel for mask language model from pre-trained. Yes, this is what we are familiar with. Yes, auto-tokenizer from pre-trained. Yes, yes, yes. Here we go, our model. Yes. Torch logits. Yes, the data set. To showcase domain adaptation. Hey, maybe it's getting interested again. We'll use the famous large movie review database. Yes, yes, by fine-tuning distilled BERT on this corpus. Yeah, fine-tuning a BERT model. Yes. Now it gets interesting. We have here our data set that we download, and as you can see, it's a dictionary with our three segments. We have the training data set, we have the test data set, and we have some unsupervised, okay, unsupervised. Train test, yes, shuffle, you do the shuffle, pre-processing the data, autoregress and mask language model. A common pre-pro step is concatenate all the examples and split the whole corpus into chunks of equal size. Okay. Truncation is true. Yes, yes, yes. Yes. The BERT-like model, we see that encoded text consists of input IDs and attention mask, our special tokens. Yes, we know this. I showed you in my video. Chunk size is 128, default to everything. Enumerate, yes. Concatenate, yes. So now let's split the concatenated reviews into chunks of the size given by the block size. To do so, we iterate over the features and use a list comprehension to create slices. The result is a dictionary of chunks for its features. Okay. Group text. What is this function doing? Concatenate, compute the length, drop the last chunk, split the chunk by maximum length, create a new label column. Okay. Tokenized datasets. Yeah. Dataset. Okay. Dataset features. Attention mask. Input A. Yeah. Nice. This is how we like it. Grouping, chunking tag produced. Yes. And you see overlapping movie. You can see 2 overlapping movie reviews. One about a high school movie and the other about homelessness. Ask language model. Yeah. Fine-tuning the still BERT with a trainer API. Okay, trainer API. We need a special data collector. Mask some of the tokens. Okay. Yes, okay. Transformer, probability. Whole word masking data collector. Nice. Nice code. I can use this. Try some samples. Take a while and go collab. Yes. Okay. HuggingFace import. Create a new data to train a test split. Yes, next thing to do is to log into the HuggingFace Hub and upload. Okay, yes, upload everything, the trainer. Perplexity for language models. Hey, what is perplexity? Nice, okay. Text classification, question answering, label. Good what makes a good language model? This is a question that is quite of some interest, yes. Okay. Assuming a test set consists of sentences that are grammatically correct, then one way to measure the quality of our language model is to calculate the probability it assigns to the next word in all of the sentences of the test set. High probability indicates that the model is not surprised or perplexed by the unseen examples and suggests it has learned the basic pattern of grammar in this specific language. There are various mathematical functions of perplexity, but the one we'll use defines as the exponential of the cross entropy loss. Hey, nice! Calculate the perplexity of our pre-trained model using the trainer evaluate. Yes. Interesting. I don't know about this. I have to read this in detail. We fine-tune with accelerate. Okay. Using our fine-tune model. Yeah, here we go with our pipeline. Yeah, we have the fill mask task and then our model. Okay, feed the pipeline. Our model has clearly adopted its weight to predict words that are more strongly associated with movies. Yes, this was the thing of fine-tuning your model. Oh, this is it. This wraps up our first experiment of training a language model. In section 6, we have to go back. We learn to train like GPT from scratch. Hey, this is nice. GPT-2 from scratch. Okay. Translation, question answering, how to ask for help, building and shares demos, HuggingFace Course event. Okay, this was it more or less, no? Section 2, library, organizer, QA pipeline, byte per encoding. Hey, I have my own video on this. Okay, I see. I just see why people do not click my video, but they click this video. Okay, word piece tokenization. Yes, our old friend. Unigram. Cool. Building a tokenizer check. Okay. Training algorithm. Okay, standard. Yes. Back to the training. Yeah, okay. Unigram. Okay, I think this sums it up. Half an hour. Gee. What we learned. We learned there's a beautiful dataset library part in this HuggingFace course. It gives you a demo, how to create your own dataset. You can open it at Colab. Beautiful. Come on. Create your own dataset. Okay. Need to set up Git, of course. Notebook login to HuggingFace Hub. Okay, import your JSONs, your token. Yeah, okay. Then you just have here, okay, in Colab, all the text we looked at in the documentation. You have now executable. Okay, this is but more or less exactly the same, because this is just a one-to-one from what we just ran through together. But it's nice that there's a Colab notebook operational, that we can run the models through. Okay, I hope you enjoyed it. If you are not familiar with HuggingFace, the course, have a look at the course, look at the chapter you're interested in, get an information, maybe you find new elements. If you're new to the subject, HuggingFace, highly recommended, whatever you're looking for. Create your own data set. And my next video will be that I will create maybe a short demonstration data set, and I show you what I need, a task-specific creation, of course. I will show you what you have to watch out for when you create your own data set, either for the lexical overlap or for the semantic correlation between the different functions. But this is it for today, and I see you in the next video.